Hello, Osisiak7. This is a reminder that TTS only works in English. Please use English in chat. Thank you.
Okay, we should be back, this time with audio. Okay, welcome back after some technical difficulties. This is Automat live coding, although we are not going to do any live coding today. Today I am going to talk about Wayland and X11. I am going to talk about them because within Automat there are implementation of those two different protocols. So to anybody who doesn't know, what is Wayland? What is X11? If you're a regular computer user, you shouldn't really care about this. This is about how applications display their windows in the operating system. This is what, on Linux, this is what allows applications to say, hey, this is my texture, show this to the user. And X11 is actually a very old protocol that apps can use to display their windows. X11 is used, for example, by this window here, Emacs. I'm talking about this specifically because this topic is very close to me because Automat needs to display other apps. So it is an X server and a Wayland compositor. It can display other apps. That's the thing. Automat can display other apps, so you can run other apps within Automat. And they work. So this is actually slightly buggy, it's kind of slow, so I had to stop this. So Emacs is using the X11 protocol. It's slow not because of the X11 protocol, it's slow because of bugs that I made. And there is another app called Kitty. This is a terminal emulator, and Kitty is using Wayland. It also runs here. I can click, do stuff here. Now close it, start it. It reacts to mouse, keyboard, and so on. So I am going to talk about X11 and Wayland because I am kind of unhappy about some misconceptions, and I see those misconceptions being repeated all over the place. And I kind of understand where they are coming from. The misconceptions are that Wayland is the better kind of protocol. It's not entirely true. It is the more modern protocol, but it's definitely not the more advanced one. And it's definitely not the more secure one. It's actually... But let's start at the beginning. So Wayland was created about 20 years ago, almost 20 years ago, when the maintainers of the X11, of the Xorg server, when they became tired of maintaining mostly legacy infrastructure. Totally understandable. There's actually a big problem in technology. It's that when you're a programmer, when you have to maintain some piece of software, you do not get as much recognition as when you create a new piece of software. So maintaining old Xorg server wasn't really that much rewarding, and programmers who maintain old software, it's just basically a rule of the universe, are motivated to abandon this old software and to rewrite it and to, get credit for being the authors of the new software, which replaces the old one, right? Even if the old software doesn't really have any fundamental issues, it's still, I guess, more rewarding for programmers to rewrite stuff from scratch. So programmers love to seek reasons to rewrite software, and one good reason to rewrite software is security, right? Old software was created a long time ago, before the internet was even a thing, so it doesn't really take into account the adversarial nature of the modern ecosystem. If internet, you have adversarial actors from foreign countries who will try to compromise your computer, to mine Bitcoin, create botnets, and maybe take advantage of your personal information. So the X server was created way before that became an issue. And the new Wayland is supposed to address those issues. The new Wayland protocol is also supposed to be more efficient and more robust, to misbehaving clients. So I want to address those problems, and one more, which is, I think, the biggest one, which is actually a step back in Wayland, and this is the modularity of the desktop. So let's start with maybe the core protocol, because the core protocol is actually not that different. The protocol which runs under the hood in X11 in Wayland, it's basically identical. It's so similar that if you connect a Wayland app to the X11 socket, it wouldn't work. Obviously, it wouldn't work, but it almost would work because the protocols are just so similar. They serialize data in almost the same way. Maybe X11 was big endian, Wayland is little endian, so there is a small difference there. But they exchange the data over Unix sockets. They use those Unix sockets to exchange also file descriptors. So if you have some larger payload of data, it will be exchanged not inline as data copy, but as a file descriptor being sent over the socket. They both use POSIX shared memory to exchange bitmaps. And they use Linux DRI to exchange GPU buffers so that an app can exchange textures on the GPU without copying data to the main memory. And this is identical. There is zero difference between X11 and Wayland here. So what is the difference? The difference is largely within where the objects live. So Wayland tries to embrace a sort of an object-oriented structure where in Wayland you actually have a concept of objects which exist somewhere, and the clients, they can tell the user, hey, I want to create a mouse object. And the Wayland server, sorry, I said user, I meant server, creates a kind of mouse object for the client and starts reporting events on this mouse. And this is actually interesting that the object ownership model in Wayland, it's kind of a little bit backwards. It allows the clients to create objects which do not necessarily exist. Like I said, mouse, like an app, like a terminal, this terminal, it actually creates a mouse handle within the server, even though I might not even have a mouse in my PC. It still can actually create this mouse object. And Wayland also has some lifetime issues. So these mouse objects, if I unplug the mouse, for instance, I can do this, or I can unplug my keyboard. In Wayland, this information is not really propagated to the client properly. I mean, it is propagated, but the client can maintain this handle to the keyboard or the mouse, and the server is responsible for keeping this handle alive and behaving as if this was a properly functioning mouse or keyboard, even though it's gone from the system. And those are very concrete examples, but if you look in the objects behind the scenes, it actually becomes more complex when you talk about other objects, not necessarily mouse or keyboard, but other temporary things that can be created and destroyed, like keyboard layouts or various other intermediate objects, which are like positioners or viewporters. There are those things in Wayland that exist there under the hood that they just create a lot of mess in the protocol, and it's easy to forget them, and it is entirely up to client to manage them properly. Server is kind of like, it has to obey whatever absurd things the client will do. So the protocol kind of allows the client to do some really crazy stuff, but on the other hand, the server can, in some cases, decide that the protocol has violated, the client has violated the protocol, and the connection has to be terminated, the client has to be immediately shut down. It also happens. So it's very weird to have a protocol which on the one hand it's very permissive for the clients. It allows them to do crazy stuff. And on the other hand, it allows the servers to terminate the clients if they think that the clients misbehaved even a little bit. So this object management works completely different in X. So X is more like X server is more like a JSON object. So in Wayland, or in Wayland, clients manage objects or handles objects. And they have this underlying model that whatever the client believes to be true, has to be true. So server has to pretend that it's all right. So if a client sends messages to a dead objects, and it may seem like this is a good idea, but this is not a good idea. So clients manage objects, then the server is kind of permissive to weird clients, but sometimes it's this twitchy killer where, you sent the wrong ID, like the ID was not sequential, the client has to be killed. So this issue that clients being killed when protocol error happen, this usually happens due to actual issues in the clients because Linux kernel and the transport mechanisms, they don't usually introduce any issues. But still, it's a very strange protocol. So in X, how does this work in X? I said that X is kind of like a JSON object. It's true. In X11, essentially, the way that... So what X server is like a huge JSON object where individual sub-objects are managed by clients. And actually, it's not even going far enough. It's not that, sub-objects are managed by clients. Any client can manage any part of this tree. Pretty much. This is how the X protocol works. X server the X clients can modify this tree however they like. And the important things are the protocols. So what are the protocols? Protocols are the conventions about what is really in this tree. Protocols tell you that if a client comes up, a new window is displayed, it should be registered as a new object with, the screen dimensions and this JSON object. It's not quite a JSON object, it's actually some just in-memory object with properties. It can have some bitmap attached, and this bitmap should be displayed on screen. And because X server is this, it's just like a database. It's a database essentially. It's your desktop database that contains the information about the windows on your screen. because of this property, the X protocol, this approach, it is extremely flexible. You can have apps that manipulate windows of other apps. For example, they can inject their overlays, they can reposition them on screen, they can manage them, they can start and stop those other apps. The X protocols tell apps or clients how to talk with among themselves using the X protocol. Okay, and because in X11 the X server holds this consistent state of your desktop. So at any single moment, you can ask X server, hey, what's the state of my desktop? And the X server will tell you, okay, at this moment of time, this is how it looks. In Wayland, this state does not even exist. And not only that, in Wayland, apps are isolated. So every app can display its own contents. It can receive the, oh, this is the mouse pointer at this point, but only when the mouse pointer is over the window of the app. When the pointer is outside of the app window, anything can happen. The X server is not going to tell you, the Wayland server is not going to tell you because the point of the Wayland is this isolation. The goal is to security. The goal is to isolate apps so that a misbehaving app is not going to have access to all of the windows on your desktop. It's not going to be able to keylog you or spoof or record the mouse position. So, is this true? Is this really true? Not quite. Not quite. Because Wayland forgets one very important thing. Desktop apps run with the same privileges as the desktop server and other Wayland apps. So this whole security argument, which is behind Wayland, is just invalid. It does not work. It's not really a security layer. So and this is the crazy thing. Like the whole isolation that Wayland introduces to make your desktop more secure, it's pointless. It's totally pointless. So, to be fair, it is possible to run a Wayland server with root privileges and isolate it from apps, but even then, other Wayland clients run with the same privileges as, as malicious Wayland clients. So this is totally made up. Like all of the portals are a mechanism that Wayland uses to request privileges. So when an app wants to record, for example, your keys, because sometimes an app needs a keyboard shortcut. So the way that Wayland solves this is that when an app wants to register a global keyboard shortcut, it will show you a pop-up asking you, hey, this application wants to listen to, for example, Control F1. Do you want to allow this? And you have to allow this so that an app can register a shortcut. This is pointless. So an app can actually, a malicious Wayland app, it can inject its own, basically, keylogging to other apps, and that's it. Like, Linux allows this. As long as you run with the same user account, one application can modify the memory of another application. So, not the same UID. It's just possible on Linux. The UID may even be different. So, Wayland doesn't really give us greater security. Wayland is actually a step back in terms of modularity of the desktop, because all of the functions which on X11 are distributed. So on X11, all of your desktop is rendered by many different apps. You have the toolbar. Toolbar is a totally separate app. You can pick whatever toolbar you want on X11. You can pick whatever window manager you want. Window manager is the one responsible for window decorations and positioning of windows. Then there is window compositor, so the app which actually displays the windows on your screen. And on X11, each of them is a totally separate app. Your desktop, it's a separate app. Your application launcher, a totally separate app. All of those are totally separate applications. And on X11, and this is like one of the cool things of building a Linux desktop, is that, hey, you can really pick and choose whatever apps you want. You can find your favorite toolbar, and you can run this favorite toolbar. You can find your favorite window manager, favorite compositor, like with some fancy animations. You can pick your favorite desktop app, which is going to display some, I don't know, some animated desktop or some cool widgets on the background. You can pick your favorite application launcher, and you can mix and match whatever apps you want to create your, ideal desktop. This is how X11 works, and this was like the core part of Linux. Was because Wayland showed up, and in Wayland, apps are isolated, so this whole mix and match, it's no longer possible. Why? Because security, because of this fake security which doesn't even make sense. It doesn't even hold. Apps in Wayland live in isolation. In Wayland, what you install is you pick a Wayland compositor. And Wayland compositor bundles everything. You get the same desktop, the same toolbar, application launcher, all of your desktop components, like pointer managers, you can have different cursor manager. In Wayland compositor, everything is built in. So you have pick one of a few big ones. So you have a GNOME, you have KDE. KDE is actually a decent one. KDE is fairly modular still. You have tons of WL roots. WL roots compositors, they're actually slightly better than most of the others because they allow some kind of composability. And the problem here is, if you want to really create a customized desktop, the only way for you is to basically roll out your own custom Wayland compositor where because this is the only place where you can still control how your desktop behaves. Toolbars, how windows are managed, how windows are decorated. We kind of lost that with Wayland. It's like all lost for the sake of fake isolation. Yes, so I am very unhappy with the current development. I really think that this model of X11 is just strictly better. It's just strictly better architecture. It's like there's no way, like everything that's actually the advantage of. Okay, let's talk about things that are claimed to be advantages of Wayland, because some people will say that, hey, but Wayland has HDR color, or Wayland has some other new feature like fractional scaling, HDR color, and maybe some more others. Maybe let's say VRR refresh, variable refresh rates. I'm not sure if variable refresh rates are there, I'm just making this up. But let's say Wayland has those advantages, even made up ones. Like I'm making up advantages of Wayland. Wayland could have, and let's even say Wayland has better security. None of those is actually impossible to do in X. Like each of those is just a matter of slightly different protocol, which could still function in this better architecture with this centralized architecture where you have a single well-defined state of your desktop and other apps can kind of mess with it in a modular fashion. This is, so fractional scaling, it's not an advantage of Wayland because it could function in X11. It's not incompatible with X11. It's just a matter of this protocol only being implemented in Wayland. So HDR color, same thing. Each window could define each HDR color. You could have other apps, for example, HDR managers that would participate in this modular X desktop and, for example, help other apps, which are maybe older apps, which do not support HDR and kind of do some tone mapping or improve their display so that they are HDR compatible. The same with fractional scaling. So in X, we could have kind of fractional scaling polyfill. That upscales low resolution apps to high resolution using some upscaling algorithms. SDR? Is this called SDR? Non-HDR apps? I think they are called SDR. Variable refresh rates. Probably also here in X server, where everything is modular, we could probably have a modular solution that would help other apps work with this new. And security is the last one. The worst part about security, to me, is the fact that it's all... So, big part of working in security is understanding all of the workarounds that exist and that potentially could exist. Because a lot of the security problems are purely theoretical. This is something that you will realize only if you are a security engineer. You will have a lot of hypothetical security issues which haven't materialized. And your responsibility as the engineer is to have a good intuition about which ones of them are actually valid, which ones are actually worth addressing before they become a problem. And the thing with Wayland is that it made up a security issue which didn't exist. It made worse architecture because of this made-up security issue, and it doesn't even address the real security issues. And there are real security issues, and they could be handled better with X. How? It's that there is a genuine problem with open source security right now, because security of software relies largely on reputation. So when you run some software, you kind of rely on the reputation of the company or the person who made the software that it's going to behave properly. And this reputation has some issues. Recently, we've seen that apps, the maintainers of open source apps, they can be malicious. They can hand off maintenance to other actors who can exploit. There was this famous XZ exploit, where basically malicious maintainers. Maintainers can become malicious, and it's possible for malicious actors to kind of farm reputation, for example, by some social boosting and those kind of things. Especially state-sponsored actors, or so-called APTs. So this is a problem, and guess what? In X, those problems, they could be addressed in a way better way than in Wayland, because in X, you could set up a properly isolated X subservers, so that if you have a potentially malicious app running in some container, that potentially malicious app would talk with a proxy X server, so it wouldn't see all of your desktop. It would just get access to some fake limited version of your desktop, or even just a fake, desktop where it could just display itself without seeing all the other apps. So it could do proper isolation, and for this reputation issue, this is the big one. X, because you could theoretically scan all of the apps that are displaying stuff on your desktop. You could have so you could integrate reputation verification or security scanning into your desktop. So those security scanner, they could literally scan your X desktop for apps which are potentially modified or potentially tampered, and highlight to you, hey, do you know that this app that you are running, it probably came out, nobody has verified it. It wasn't, reviewed by anybody. It's not part of any major repositories. You're kind of on your own here. So in X, if the transparency was greater, if you could literally see all of the apps which are displaying the stuff on your desktop, you could have much better security. In this different model where you do not isolate apps for no reason, for some made-up reasons. So all of those arguments, advantages of Wayland, are false. None of this is true. This is false. This is false. false. I made up those variable refresh rate. I don't know if they are there. Better security, false. So this isolation thing, it really could be handled better because right now, every Wayland compositor also needs to be a sandbox. In X, every X compositor or server, or we do not have a single compositor. You do not pick one in X. In the world of X, you compose your desktop of many modules. But in X, you can have a proper isolator, which ensures that a malicious app is not going to attack your desktop. So, like, all of the issues that we have right now with Wayland, they kind of stem from this misguided switch to an isolated architecture. Like, and Linux desktop could genuinely be better if we didn't do that. I really honestly feel we are moving in a bad direction with Wayland right now. And it feels so bad to me to see this and to see this regression happening. It's really like seeing something being destroyed and, people cheering and being happy that it is being destroyed. It is actually a very tragic thing. This is kind of the tragedy of Wayland. Okay, so I said this is going to be a shorter stream. I want to end now, but before I end, I want to say some good things about Wayland because it actually did some good things. So what is good about Wayland? So the protocols in Wayland, they are designed and published at a higher rate. It actually genuinely motivated many people to propose and publish new standards. So yes. The problem is that most of this stuff was already there. It was already there in X. It's just reinventing stuff. But still, there are some new things which are part of Wayland, which are genuinely fun. And the fact that people have motivation to work on them, I guess this is some kind of success. Maybe not a technical success, but an organizational one. So I'm looking at free desktop Git repository. It's not really moving very fast, but I guess it's better than the legacy X extension thing. So another nice thing about Wayland protocols is that more of the protocols are machine parsable. So before that, in X, you had those extension documents which described how messages are being exchanged. So it was very message-based. The messages were well described. But now in Wayland, I think the descriptions are much nicer. They work better. Okay, so not everything is bad, but still, I would say that the fact that people are motivated to work on new, Wayland compositors, I think this is actually the result of a problem. It's the fact that people lost the ability to customize their desktop. Like, if you have the GNOME desktop, you cannot customize it really. The only way to customize your desktop is to basically reinvent a new Wayland compositor. So it really kind of shows the tragedy and the fact that there is an underlying problem here.
Bartek says,
I still can't justify to spend time for migration from Z11 to Wayland. It just works.
Yeah, still works. X11 is kind of still updated. It still receives some updates because there is still X-Wayland. X-Wayland still receives those updates. Anyway, there is this kind of diagram that shows different architectures in software. In software, you can have this star architecture where every app can talk to any other app through some protocol. And the number of connections that you have to implement in this architecture, in the star architecture, is the same as number of apps. So each app only needs to talk to this single protocol. And there is another architecture which is end-to-end, like where every app needs to talk with every other app compositor. The number of connections in this architecture is n squared. And in Wayland, because we have so many Wayland compositors and Wayland compositor bundles, all of this, and all of the protocols, I think Wayland is much closer to this n squared architecture, so it requires way more kind of code to provide the same number of functions, the same level of interoperability between apps, because every app needs to learn to talk to every other app, rather than talking through some well-defined central server. Anyway, I want to do one more thing at the end. I said some good things about Wayland, but I think there is potentially a better architecture which is compatible with both X and Wayland, which is using the X architecture, but still allows the apps to interoperate with one another. But, somebody must design it. Somebody must come up with it. We need something that will bring back the interoperability of X to this modern system and still have people motivated to work on this. Because I just cannot look at the stuff that we are losing when we are migrating to Wayland. This interoperability, the ability to compose your desktop out of tiny Lego blocks, that was amazing. That is amazing because you can still run this, but for some reason, for some crazy reason, for some kind of mass hallucination, we are leaving this behind and everybody's clapping. This is a tragedy. So we got to do something about this. But I'm not going to give you answers. You have to come up with answers yourself. Okay, I got to go. See you.